Hello all. So in our previous video, we have seen more FSM for overlapping case. Now in this video, we will see more FSM for non-overlapping case. So, we have covered this for 1011 overlapping case. We have covered in the last previous video. We have also covered the how to write VHDL code and all. So now for non-overlapping case, what will be considered? Like when you see this example, uh, for non-overlapping case, we will not consider the ones that are used earlier. Like we have to detect 1011 in the sequence. So 1011 is come one time here, and after that 1011 is one time here. So non-overlapping case, we consider one bit on only one time. But in case of overlapping, we are considering like 1011 here and other 1011 here, and by taking this 1011, so we are considering three times for overlapping case. It is detecting uh, three times, but for non-overlapping case, it is detecting two times for same sequence. So this is the state table of Moore machine for detecting 1011. Like for S naught, when S naught is 0, so state should remain on S naught. But when S naught equal to S naught detects 1, then it will go on S1. And for S1, if one is there is 1, then it will remain on S1. But if it detects a 0, then it will goes to next state. Why so? Like our sequence is 1011, but if here it detect 1, so it should remain on same state. Similarly, for S2, when it detects 1, it will go on S3, but when it detects 0, so our sequence will become like 100. So it will be the same case like 00. So it will go on S0. For S3, when it detects 1, it will go on S4, and our output will become 1 because 1011 is detected here. And if it detects 0, so our 1010 like sequence becomes 1010. So it will the same case that we got in S2, like 10. So our for 0 case, our state goes to S2. So and at S4, when the sequence is detected, if we get bit 1, then our sequence will start from S1, and if we get 0 bit, then our sequence will go on as 0 bit. Like this, we can draw the diagram for Moore machine, and we have written the state table. Like this is same that we have that what we have explained in the previous slide. Like for S0, the current state for input X0 equal to S0, but for next state, the input X1, the next state is S1. Similarly, for S1, for X0 is S2 and S1. So like this, you can see. Now we will see the code of code for non-overlapping case. So it is same as that we have written in the overlapping case. Like first of all, we have declared IEEE library. After that, we create an entity Moore machine, and we have declared a port X1 as and clock as input port, and Z1 is as output port. After that, we have started the behavioral architecture of Moore machine. So we have defined the state S0, S1, S2, S3, and S4. After that, we will process present state and X1, like when we got any change in uh, present state and X1, then this statement will execute. So here we have written the case for present state. Our present state is like when S naught, then the output is Z naught. Z1 is equal to 0, that we know. And if X1 is 0, then next state is S0. Like similarly, else next state is S1, and we will end this case. So similarly, we can write for S1 and S2 and S3. But so this is the code for overlapping case. So in what we'll do in non-overlapping case, our only one state is changing. So for S4, when X1 equal to 0, our next state will go to S0, not S1, S2. So now we can see this. So our next state will go on S0, and our output is detected as 1. After that, we will end the case statement and end the process statement. And after that, we will wait. We have here we have defined that clock take event and clock equal to 1. Then the present state goes to next state goes to present state. And after that, we will end the process and end the behavioral modeling. So this is the RTL symmetric of Moore machine. So here one clock and X1 our input and Z1 is like an output. So for this sequence, this is our input and output. This output waveform for non-overlapping case, and this output waveform for non-overlapping case that I have told you earlier. Like for non-overlapping case, it will detect only 2 times, 1011 this one and 1011 this one. So our output is high 2 times here, like you can see. But for overlapping case, it will detect 3 1011 1 time here, 1 time here, 1011, and 1 time considering this one 1011 here. So our output is high 3 times for overlapping case. So like this, you can see you can do any type anything. So thank you.